Something is out there, far past Neptune, in a stretch of the solar system so remote and so cold that sunlight barely registers. A cluster of icy worlds is behaving as though it's being steered. Their orbits lean and stretch in ways they simply shouldn't, as if some massive object, patient and invisible, is nudging them from the shadows. Run the numbers and the same answer keeps surfacing. A planet, not a small one either, something perhaps 5 to 10 times heavier than Earth, gliding along an orbit so wide and so slow that a single trip around the Sun could take tens of thousands of years. There's just one problem: nobody has ever seen it. For over 100 years, astronomers have hunted for a large planet lurking at the fringe of our own system. And for over 100 years, the sky has offered nothing but silence. It's a strange thing to sit with. We photograph worlds orbiting other stars. We capture the faint glow of galaxies that switched on when the universe was young. And yet, a body larger than Earth could be sitting in our cosmic backyard, and we'd have no idea exactly where. But that silence may finally be breaking. Not long ago, a small research team went digging through observations captured by a satellite that launched 4 decades ago, data most people had long since stopped thinking about. They paired those old readings with a newer survey, lined them up across time, and found something that made them look twice. So the question I want to explore today is a big one. After a century of empty searches, have we finally caught our first glimpse of the missing planet? Come with me out to the very edge of the solar system, to the dark territory where this world is thought to hide. We'll walk through exactly what these researchers found, unpack how you even go about proving a planet exists when you can't point a camera at it, and ask whether the next generation of telescopes is about to hand our solar system a 9th planet at long last. Because if this holds up, every textbook, every classroom poster, every model of our neighborhood gets rewritten, and the story starts not with the planet itself, but with the strange little worlds it seems to be pushing around. To understand the puzzle, you have to appreciate just how empty and how far away this region really is. We're talking about distances where the sun shrinks to little more than a bright star, where light itself, the fastest thing there is, needs more than 8 hours to cross the gap. That's around 9 billion kilometers from home. Out there, warmth is a memory and the sun's grip grows thin. Scattered through that darkness are countless frozen bodies, most of them so faint we can barely register them at all. Astronomers call them trans-Neptunian objects, chunks of rock and ice orbiting beyond the 8th planet. The first one ever spotted is a name you'll know well: Pluto, found by Clyde Tombaugh back in 1930. Remarkably, it then took roughly 6 more decades before anyone located a second. Since then, the floodgates have opened, and today we've catalogued close to 5,000 of these distant worlds. The real turning point came in 2003. A team at Caltech, led by astronomer Mike Brown, went looking in this outer wilderness and turned up a world they named Sedna, a dwarf planet smaller than Pluto, following an orbit that made no sense. It was steeply tilted and wildly stretched, swinging far out into the dark before looping back. On its own, one oddball orbit could be shrugged off as bad luck. But Sedna was only the beginning. As the telescopes kept sweeping the region, more of these misfits turned up, and they were all peculiar in the same family of ways. Some plunged inward far enough to cross Neptune's path. A handful circled the sun backwards against the grain of every major planet. Many rode along on steeply inclined tracks that had no business being there. And crucially, a number of the most distant ones seemed to be pointing the same direction, their long orbits loosely clustered together like arrows leaning the same way. That clustering is the heart of the mystery. Orbits don't organize themselves for no reason. something has to be hurting them. So astronomers were left with a genuinely uncomfortable question. What could reach all the way out here and comb these scattered worlds into a pattern? Answering it would send them chasing one of the boldest ideas in modern astronomy, that a ninth planet has been hiding in plain sight the entire time. There was really only one mechanism that could tie all these behaviors together. It's a gravitational dance known as the Lidov-Kozai effect, and it needs exactly 3 players: the Sun, one of these distant icy objects, and a third, far-off body massive enough to pull the strings. Under the right conditions, that hidden third party can slowly trade an object's tilt for stretch, reshaping a tame orbit into the extreme elongated paths we keep finding. In 2016, Mike Brown and his Caltech colleague Konstantin Batygin put this idea to the test. They modeled the movements of a set of the most extreme distant objects, 17 of them, and asked how likely it was that their alignment was pure coincidence. The answer was almost absurd. The odds came out at roughly 6 in 10 million. In other words, chance was off the table. Something with real heft was out there shepherding these worlds. They gave it a name that instantly caught the public imagination: Planet 9. Here's where you'd expect the story to get easy. If a planet is sitting in our own solar system, surely we just aim a telescope at the right patch of sky and take its picture? If only. Spotting a world this far out is brutally hard, and the reason comes down to light. A planet out here doesn't make its own visible glow. It can only shine by bouncing weak sunlight back at us. That reflected light has to make the punishing journey out and then all the way back, which means its brightness collapses not with the square of its distance, but with the 4th power. Double the distance and it doesn't get 4 times fainter, it gets 16 times fainter. At hundreds of times the Earth-Sun distance, a super-Earth becomes a needle in an unimaginably dark haystack. And we have looked. Several of the most powerful visible light surveys ever built, the Zwicky Transient Facility, the Dark Energy Survey, Pan-STARRS, have spent years combing the sky for exactly this kind of slow-moving speck. Every one of them came back empty-handed, not a single confirmed candidate. Every planet radiates heat. Even a frozen giant, far from the sun, glows faintly in infrared light. The part of the spectrum our eyes can't see, but our instruments can. A team based in Taiwan, led by Professor Tomotsugu Goto, alongside a determined PhD student named Terry, realized this opened a completely different door. Instead of hunting for reflected sunlight, why not hunt for the planet's own warmth? To do it, they turned to 2 of the most ambitious surveys ever flown. The first was IRAS, a satellite that mapped the entire infrared sky back in 1983, lifted above the smothering warmth of our atmosphere and chilled by superfluid helium to just a couple of degrees above absolute zero. It picked out hundreds of thousands of new infrared sources, galaxies, asteroids, dust, all of it. The second was AKARI, a Japanese mission launched in 2006 whose name fittingly means light. It saw the sky in sharper focus and reached into longer wavelengths than its predecessor. Together, these 2 surveys held more than 2 million catalogued objects, an ocean of data separated by 23 years. And that gap was the whole point. A planet as distant as this one would crawl across the sky, but it would still shift a measurable amount over 2 decades. So the team combed both catalogues, tracking objects one by one, searching for anything that had moved by just the right amount and in just the right direction to match a Planet 9 orbit. They had a precise portrait of their quarry, or a world somewhere between 7 and 17 Earth masses, dipping to around 280 astronomical units at its closest approach, and swinging out to roughly 1,120 at its farthest. Since other teams had already picked over the nearer distances, Terry concentrated on the stretch between 500 and 700 units, the zone where such a planet, moving sluggishly near the far end of its orbit, would linger longest and be easiest to catch twice. Out of more than 2 million data points, the filters left 13 possibilities. Then, checking them one at a time by eye, Terry narrowed it to a single survivor. In the older image, a small knot of pixels sits slightly warmer than the darkness around it. In the newer one, taken more than 2 decades later, a matching warm spot has drifted across the frame by roughly the width of 1.5 full moons. Exactly the lazy shuffle you'd expect from a planet loitering at the solar system's edge. It's not proof. Seen cold, those specks could be almost anything. But the numbers line up unnervingly well, and the researchers are cautiously thrilled. Not everyone is sold. Brown and Batygin have pointed out that the candidate's orbit looks more steeply tilted than their models would prefer. Settling it will take a sharper eye, and thankfully, one is about to open. High in the mountains of Chile sits the Vera Rubin Observatory, home to the largest digital camera ever built. A staggering 3.2 gigapixel sensor, it can register objects vastly fainter than anything the old optical surveys could reach, and over the coming years, it will carry out a sweeping, decade-long census of the changing sky. Each night, it will pour out around 20 terabytes of fresh data, and by the time it's finished, it could multiply the number of known objects in our solar system by a factor of 100. If Planet 9 is real, and roughly where the models say, this is the machine most likely to catch it in the act. Even Mike Brown has admitted that if someone handed him the funding to build the perfect planet-hunting instrument from scratch, he'd essentially end up building Rubin. Meanwhile, the Taiwan team isn't sitting still. By sifting their infrared data in a slightly different way, they've already flagged 2 more candidates worth chasing down. But here's the honest part of the story that often gets skipped. What if we point every telescope we have at that patch of sky, and there's simply nothing there? A theory this bold has to survive that possibility, and it turns out the clustered orbits could have other explanations, some of them just as strange as a hidden planet. The first is that there may be no single culprit at all. Instead of one heavyweight, picture a vast belt of debris out beyond Neptune whose combined gravity does the shepherding. This is the idea behind what's known as the ZM belt, named for the 2 researchers who proposed it. If enough mass, perhaps 10 to 20 Earths worth, spread across countless small bodies, is riding out there together, their collective pull could naturally coax the distant orbits into the very clusters we observe, with no giant planet required. And conveniently, Rubin's decade-long survey should be able to reveal whether such a belt truly exists. The second possibility reaches back in time. Long ago, a passing star could have swept close to the young solar system and dragged these outer worlds into their odd arrangement, a gravitational encounter that ended eons before humans existed, leaving only fingerprints in the orbits behind. And then, there's the strangest option of all. What if the solar system didn't merely get grazed, but actually captured something, and that something wasn't a planet at all, but a primordial black hole? These hypothetical relics of the early universe could carry a planet's worth of mass while being no bigger than a grapefruit, utterly invisible unless it happened to be devouring something nearby. Astonishingly, some researchers argue that snagging such a black hole is roughly as plausible as snagging a planet of the same weight. There's even a camp that says we don't need any hidden object at all, that our very understanding of gravity is what needs adjusting. But whichever answer turns out to be right, they all share one thing in common. Within a few short years, the sky itself is going to tell us. So let me put the question to you. If we could reach out and know for certain what's tugging on those distant worlds, what would you want it to be? A genuine ninth planet? A swarm of hidden debris? A silent black hole no larger than a piece of fruit? Or proof that the rules of gravity themselves need rewriting? I'll be honest about where I land. For those of us who grew up memorizing 9 planets before Pluto was quietly reclassified, there's something deeply satisfying about the thought of returning to that number, of finally filling in the last blank space on the map of our own neighborhood. A planet would feel like closure, like the solar system handing us the final piece of a puzzle we didn't even know was incomplete. But maybe that's the wrong thing to hope for. Because whatever is out there, it's already teaching us that the place we call home is far less finished, far less mapped than we like to pretend. For 100 years, this thing has stayed just out of reach. And now, for the first time, the tools have caught up to the mystery. The Vera Rubin Observatory is watching. The old data is giving up its secrets. And the answer, planet, belt, black hole, or something we haven't even imagined, is finally within reach. I genuinely can't wait to find out what's hiding in the dark. If you enjoyed venturing out to the edge of the solar system with me, tell me in the comments what you're hoping we find, and stick around for the moment we finally settle it. The map of our solar system has one last blank space, and very soon, the sky is going to fill it in. Subscribe and be here the day it does.